Welcome in. Here is our learning outcome for this video. We want to learn about significant figures, determine how many sig figs are in a certain value, round numbers to the correct number of sig figs, and figure out how many sig figs to keep when doing calculations. We said in our last video, the number of digits that we report in our number tell us about the precision, tell us about how well we have measured a number. Significant figures are going to be this tool to quantify the certainty in a measurement. It allows us to report values correctly even after performing calculations. In short here, more significant figures will mean that our number is measured with more certainty. Here are some rules to tell us how many significant figures are in any given value that we might see. First, any digit that is not a 0 is automatically significant. That's a number that we measure and that we know about. When we see zeros, we need to be a little bit careful. Here are the rules for zeros. Any 0 that is stuck in between other non-zeros is going to be significant. Rule number 3, trailing zeros on the right-hand end of our number, are significant only if there's a decimal place in our number somewhere. Zeros at the beginning of our number are not significant in terms of our precision. They do tell us that that number maybe is very small, but they're not telling us about how precise that value is. Once we have our rules, well, there's always going to be a couple of exceptions. There are some numbers that are infinitely precise, that have no uncertainty, or maybe have unlimited significant figures. If it's numbers that we are counting, maybe I have 5 fingers on my hand, I'm not guessing about that. It's not maybe 4 or maybe 6. My hand has exactly 5, and I can not be guessing about that at all. Some numbers are defined definitions. They're going to be exactly 100 centimeters in a meter. We're not guessing about that either. So that has unlimited significant figures or infinite significant figures, infinite precision. We're not guessing about it. Likewise, if we have integer numbers, parts of equations, we're not guessing about those either. So those also have infinite significant figures. Let's put these to the test. We can try to count up the number of significant figures in each of these values. For question A, everything that's not a 0 counts. So we have a 5, an 8, 3, 1. We have 4 total digits. All of them are significant. We can write this as 4 significant figures. For question B, we have a 2 and a 5. Those automatically count. Now we have to be careful about our zeros. Zeros at the beginning of our number tell us that the number is small, but they're not telling us about precision. Those do not count as sig figs. Zeros to the right-hand side of our number only count if there's a decimal place. In this case, there is a decimal, so that 0 on the right has to count as well. For question C, we have a number in scientific notation. We can ignore the exponential part. We only have to worry about the decimal part for precision. And good news, everything is easy. There's never a 0 on the left. There's always a decimal place. In scientific notation, every digit in our decimal part counts as a sig fig. I'm going to skip here to E. This one's a little bit tricky. 1 centimeter is equal to 0.01 meters. This is actually a definition. And so we can write this a few ways. We can say that there are infinite sig figs, or we can say that this is exact, or we can say that this is unlimited, or we can say that this is defined. However you want to phrase this, this leads us to that same idea that this is not being guessed about at all. And so there are as many sig figs as we need, infinite. There's two more here on this slide. Let's take a minute, let's pause and try to answer those. Write down your answers for yourself. All right, as we said, we're going to do countless calculations in this course. So after calculating our numbers, we're going to have to round our values to the correct number of significant figures. We'll talk about how to decide how many sig figures to keep coming soon, but for now we can just talk about rounding. Rounding is going to be simple. We want to, once we know how many digits to keep, we want to look one extra place over. When we're doing our calculations, the calculator is extremely smart. So our example here, take 1500 divided by 0.058. Your calculator will tell you so many numbers here because it's very smart. However, we need to be even smarter than the calculator. If we get this value here, do we know this number out to that many decimal places? Probably not. We need to round this value to something that represents actually how precisely we measured it. If we're trying to round our value, say, just to 2 significant figures instead of all these digits that the calculator tells us, we can look at those 2 digits and then try to hop one spot over to make our decision. If that number one spot over is big, we can round that 5 up to a 6. If that number one spot over is small, we can round this 5 down to just 5. In this case, it's pretty big, so we can round our number to 2.6 instead of 2.586, 2.06, whatever. Oh, be careful. Make sure that when you round, you keep the value the same. It's the same number, just written in a slightly different way. The number before was 25,862. Is that going to be the same as 26 that I have written down? No, those are very different numbers. So we have to have enough placeholder zeros to make sure the number is the same. All right, 25,862 is very close to 26,000. That's a good way to round it. As we said, we're going to need a way to decide how many digits to round to. So actually, we're going to have 2 rules. The first rule applies to any combination of multiplication and divisions. The rule here says keep the fewest number of significant figures in our calculation. The top example, we have 3 sig figs, 5 sig figs, and 2 sig figs. Our fewest number is 2, so our answer has to be rounded just to 2 sig figs. Bottom example, we have 4 and 3. The fewest is going to be 3. Let's round our answer just to 3. The other rule we need to know is when we're doing any combination of additions and subtractions, instead of the significant figures, we need to keep track of the number of decimal places, or maybe the number of places in each of our numbers. One way to do this is to line up the decimal place. Another way is to think about things in terms of scientific notation. But regardless, we want to keep track of the fewest number of places and round our final answer just to that. 4.8 we know to the tenths place. 3.965 we know out to the thousandths place. The fewest number of places is that 10th place. So we need to round our final answer just to that 10th place, that leftmost spot that we know when we line up our decimal. All right, here's some examples and some practice problems. I'm going to go through number 1 and number 4. Number 2 and 3 are practice for you all. Here we go. Number 1, we have a whole bunch of multiplication and division. We need to follow that multiplication division rule. Let's keep the fewest number of sig figs. Once we get our answer, we're going to have to round it just to one significant figure. Calculator here is very smart. It tells us 0.0010775 something 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 something. We only get to keep one significant figure. So we look at our first digit coming from the left. That's number 0. We need to check one digit over. That 0 is small. So instead of rounding our 1 up to a 2, we'll just leave it as that 1. And again, let's make sure it's the same number. 0.00. If you'd rather, you can write this in scientific notation. Either answer, totally acceptable. Looking at number 4, we have a combination of addition and subtraction. Now we need to count up the number of decimal places. And we only get to keep the fewest number of decimal places. Our calculator tells us 131.108, but we only get to keep 2 decimal places. We're going to round this 0 up to a 1 or down to just 0. In this case, I want to round it up to 1. Or if you'd rather put it in scientific notation, always acceptable. Here we go, 131.1 or 1.311 times 10 to the second. We have 2 extra problems here. Pause the video, take a moment, try to do these problems, write down your answer. All right, one last challenging type of problem. What happens if we are not just doing one rule at a time? What if we have a combination of multiplication, division, addition, subtraction? Well, the key here, be careful. Don't rush. Keep track of everything as you go and follow each rule as it shows up as you're following this order of operation. PEMDAS here is the order of operations. Start with everything in parentheses. Then we get to do our exponents. Then we want to do multiplication and division as they show up. Then we get to do addition, subtraction as they show up. So don't round until the very end, but just follow each rule as it shows up and keep track before rounding. This is a little bit weird, but we'll give an example. Here's our problem. We have 3.489 times this parentheses, 5.67 minus 2.3. So we want to start with parentheses. So if we evaluate that parentheses, we get this value 3.37. Since we did our subtraction, we want to think about the decimal places. And since we only know one decimal place for this second value, we only have one decimal place. We evaluate that parentheses. We can keep track by underlining or highlighting or however you like, but we don't want to round just yet. Our calculator tells us 3.37, but we know that this only actually is known out to one decimal. If this was the final answer, we would round to 3.4. It's not our final answer, so we're going to keep 3.37, but we're going to remember or write down in our head that we actually only know this to one decimal place, or in this case, our one decimal place corresponds to two significant figures. Now we can do our second operation here. 3.489 times our 3.37. We type all of that into the calculator, and we get this final answer, 11.758. But now we're doing our multiplication, so we need to keep the fewest number of sig figs. This value has 4 significant figures. 3.37, it looks like 3 sig figs, but we underlined it to remind ourselves we actually only know this value to 2 significant figures because of that decimal place rule up above. Now we only get to keep 2 sig figs, so we'll round this value from 11.758. We'll round that up to just 12. We can do one of these as a practice example. Maybe this first one is going to be fun. We can start with that parentheses. Inside of our parentheses, we have multiplication, so we need to keep track of our sig figs. Our calculator tells us 4.9464. We get to be smarter than the calculator. Actually, we only know 2 sig figs of this number, so actually we only know 4.9, although we're not going to quite round yet. Since this number is 4.9, we know this to 2 sig figs, and we know this to exactly 1 decimal place. You can always write down how many sig figs and decimal places we know. In this case, we do need to know the number of decimal places because our next operation is to do this subtraction. 19.667 minus our 4.9464. Okay, we're doing subtraction, so we need to know decimal places. 3 decimal places for that first number, 1 decimal places for that second number. And so we get to have exactly 1 decimal place in our answer. 14.7206. 1 decimal place. There we go. This is a big one. We want to be able to determine the number of significant figures in a value, round our numbers to the correct number of significant figures, and then after doing calculations, keep the correct number of significant figures. Well, there we go. Thanks so much for tuning in. Hope you all have a great day, and I will catch you next time.